Hello, everybody. Alex, thank you for joining us. This is Alex Kendall from Wayve.
Hey, San Francisco.
Jensen Huang recently said, you're the next trillion-dollar company. Are you going to be the next trillion-dollar company?
I'd love to. We've got a bit of work to do to get there, but I mean, he just said today at the GTC conference how robotics is going to be the next platform for computing, and I really believe that. Today, everyone's talking about building GPUs and data centers, but give it 10 years, and I think it's all going to be about robots. When we think about AI in 10 or 20 years from now, I think it's, maybe, of course, the cognitive AI, the chatbots, the LLMs is so important and making all the headlines today for very valid reasons. But I think in 10 or 20 years to come, when we talk about AI, we're going to be referring to our physical machines that help our everyday lives. Of course, the platform that underpins all of that is going to generate, I think, a level of impact that maybe makes that number relevant.
Speaking of robots, I just got off the phone saying goodnight to my son back home. He had a question for you. How do you make robot cars?
The interesting thing is actually a lot of the cars driving around today are already robotic in many senses of the word, or at least they have the infrastructure for them. And I think there's been a big transformation in the automotive industry in the last couple of years that hasn't been talked about as much as it perhaps should have. What we've seen in the last couple of years is across the industry, many automakers are now building what they call software-defined vehicles, cars that have centralized computing with sensors all around them that gives you the ability to go build an intelligent platform. And that makes it possible to deploy autonomous systems. They have a lot of the right hardware on them, hundreds of TOPS of GPUs, enough sensing to give proprioception all around the vehicle, and in some cases, actually redundancy to build eyes-off or driverless solutions as well. But the thing that we've been chasing as an autonomous driving industry for over a decade is, I think fundamentally autonomous driving is an AI problem. Perception has been worked on for decades, and today is really robust, really general purpose, and to the point where I'd start to have a conversation about perception being solved. But when you think about going beyond what we see in AI, particularly with today's foundation models capable of really robust recognition, the challenge now for robotics is about behavioral interaction. And unfortunately, internet scale data doesn't get you there. But actually, autonomous driving is an AI problem, and I think we are now able to train large-scale foundation models that can start to understand not just perception, but actually complex behavior. We drove this morning through some complex scenarios through here in San Francisco. Maybe you saw some of that in action.
Yes, we got a demo of what you were working with at Wayve. I think one of the things that's so interesting about what you guys are doing is you're essentially hardware agnostic. And today you came with the light version. We were in a Mustang Mach-E. You had, what was it, the
NVIDIA Orange chip, 5 cameras.
In the back, and only 5 cameras, nothing else. No radar, no LiDAR. And I got to say, it was probably one of the smoothest camera-only drives I've ever gotten, especially given that it was only 5 cameras.
Yeah, and that's an example of the driver assistance platform that we can build. It's no HD map, 5 cameras, a single NVIDIA Orin. This is hundreds of dollars of hardware equipment, and this can drive anywhere. This year, at the start of this year, we were just testing in London, and this year we've now driven in over 500 cities around the world, through Europe, Japan, North America, and what we've seen is that this AI is truly able to generalize. It's able to recognize different road signs, different navigation layouts, and of course, respond to many of the long tail of edge cases that you see when you test at this level of scale.
I want to take a step back for a second because you mentioned a few times, and maybe people aren't fully familiar with what you guys have been doing. You've been around for a while, and you've been working on this sort of end-to-end AI solution to self-driving cars before it was something that is kind of now in vogue. You were doing it at a time when it was thought to be not the right approach. What do you mean when you say end-to-end AI? And then after that, tell me how validated you feel that people have come around to your solution.
It's been the most humbling journey. We've been working on this. I've been working on this for over 10 years. But when we started the company in 2017, the typical response we got when we said we were working on end-to-end deep learning for driving was, it's a black box, it's not safe, it won't work. And look, it's taken us a long time to go build this out, but today what I see is the quantitative evidence that shows that this system can not only achieve the level of safety or grow in the way that's required to make these products possible, but actually do it in a way that's going to be economically viable to deploy everywhere, not just in affluent areas with lots of infrastructure, but actually bring autonomy worldwide. And we're even seeing evidence of this generalizing beyond cars, but it's a really exciting trajectory. But it's been an interesting journey where ever since the beginning of Wayve, we've been all in on this. We haven't had a hedge where we've been trying to build a AV 1.0 stack in parallel, but we've been all in. And the result has been that we've built a full stack, not just the end-to-end driving model, but all of the tooling, infrastructure, the post-training customization, and all of the capabilities required to go build this. And today, we are launching this as a platform for fleets and automakers to go build autonomous products that they dream of, whether it's driver assistance, driverless, L2 to L5 applications. This is a platform that has the general ability to actually manage all of these different use cases.
How is what you're doing and how you just described it, how is that different from, we know Waymo has shifted to a bit more of a flexible model that maybe somewhat resembles what you're doing, but how is it different from what Waymo's doing?
I think there's a spectrum of approaches across the industry. I mean, you can argue about things like sensor architectures and things like that. I think that's perhaps the wrong debate to be having. What we've seen is a steady growth in the industry from, call it classical robotic stacks with many different heuristic or hand-coded components that are all fit together in rather complex architectures, to an increasing move towards consuming all of these into one end-to-end AI. And where we started was one end-to-end AI, and I think it's underappreciated the jump from going from an end-to-end AI for perception and planning to one single one, because a lot of companies get to the point where they have a single AI for perception and a single AI for controls, but the interface there between them, creates a lot of technical debt when you start to think about your safety case, your infrastructure that all leverages that perception layer. When you go to one end-to-end model, it forces you to really think about overall system safety and interpretability. And that's where we've been focused. But we started there, but we're actually starting to see one step further now, which is moving from call it a vanilla end-to-end model to now more of a, what today we call a foundation model approach, a multimodal architecture. I'll give you a sense of how multimodal and general we're trying to train this. This AI that we drive learns from a wide variety of different sensor architectures, from dash cams to surround camera, surround radar, LiDAR, or even language. And it learns from all of these for many different tasks, not just driving, but also active safety, warning, parking, ADAS features, HMI, many different driving tasks. And the result is a very flexible and general purpose foundation model that can truly understand the generality of driving, including around the world. And then when we take that and we specialize it down for a specific application, whether it's a 5-camera vehicle on an NVIDIA Orin for driver assistance like we drove in today, or it's the vehicles we're working on for robotaxi applications that we announced that we're going to launch with Uber starting in London. Whatever application it is on the spectrum, we've set out to build a very flexible and general platform. But you asked how it's different. In the market, we see a spectrum there, of course. On the one end, you've got Tesla, camera only, but we share a lot of similar beliefs about building scalable technology natively integrated into mass-produced vehicles without an HD map. On the other end of the spectrum, you have vehicles that are driving in Shanghai or San Francisco that rely on a lot more infrastructure. And I think ultimately the solution that is going to be the steady state system that we operate in the world, call it in 10 years' time, these are going to be systems that are natively integrated into vehicles. They're going to have the intelligence to drive anywhere and not rely on things like high-definition maps. And they're going to be built with scalable hardware and an end-to-end AI solution. And so we're going straight after that future. We're natively integrating in vehicles starting today for driver assistance, as well as robotaxis that aren't retrofit, but are natively integrated, mass-produced, low-cost vehicles with the redundant sensing and compute to truly make them safe.
I'm glad you brought up Tesla because I want to hear your thoughts on how you compare to what they're doing. In particular, you just mentioned something, I almost glossed over it a little bit, but I think it's really important. One of the things that Tesla claims is it is able to train its models by leveraging the fleet data. They have millions of cars on the road in many different places around the world. You're taking a similar approach, but you're getting that data from so many different places. Tell me a little bit more about the differences between those two approaches, because it sounds like yours would be harder to pull off because it's coming from so many different sources and you have to like sort of normalize them in some way. Is that the right way to think about it, or is it not?
I think, data is essential to fuel these systems, but there's a couple of things when you dig into it that become more important when you think about not just the volume, but the diversity of the data, and then how effective is your infrastructure actually finding the right things to learn from in that data. So these are some of the things that we've focused on. I think Tesla has about 5 different vehicles they sell. Typical partner of ours, like take Nissan for example, they have dozens of different products all around the world. And so when you add together all of the OEMs we work with, there's a very diverse set of vehicles, of use cases, and even some of our partners beyond automotive. What happens when we aggregate this data is we start to learn a more general purpose solution. So that's that's the first thing. And then secondly, when it comes to finding the right aspects of data to learn from, one thing we found is how important it is to be able to understand and filter the data, but do this in an unsupervised way. A lot of where we have got to is because of some of the forcing functions on our company. The fact that we have been all in on end-to-end learning and haven't taken crutches to get us to places, or the fact that we started in London, which is such a complex environment to drive in, where you're forced to learn to negotiate and merge and go through roundabouts and deal with all of the other road users, micromobility, pedestrians, cyclists that you see in London. I think one thing that's really underappreciated is that from the beginning, we've looked to build a solution that can generalize across countries and vehicles. And you could imagine if we were working with all the different partners we have with different SoCs, from NVIDIA to Qualcomm, or different sensor architectures, camera only, or camera radar LiDAR. If we had to build separate models for each of those, this would flood us and drown us in effort. But the fact that we've been able to build a solution that can naturally generalize and scale to the diversity of applications that we're building, the fact we're set up as a company with regional expertise and everywhere from Stuttgart to Tokyo to Detroit, so that we can really work with the biggest and best around the world. These are the kind of investments that have, in many ways, this innovation has been forced on us by the constraints on our company, but today I think is turning into a strength that can let us succeed.
You didn't deviate from that course, and now it feels like it's validating on the other end of it, but were there ever moments where you thought, we're on the wrong direction, right?
Oh man, it felt like the first year of the company, we were just trying so many things for the first time. We built the very first reinforcement learning system that learned to drive a car. Very basic lane following, but from that to the very first sim to real system that trained purely in simulation, to the first language model for cars, or the first generative world model for driving. Throughout our history, we've had a rich set of investments in frontier embodied AI science. And it felt like we quickly made some breakthroughs, and then, like with most machine learning systems, there was a period in the middle of a lot of infrastructure build out. How do you train at scale? How do you measure? How do you build the ship as we're flying it? We need to build the company around it. But today it feels like all of this is coming together as a dam bursting of now it can come out across the market with the strength of us as a company to actually go and bring this to market. But that hasn't happened overnight. It's been a decade of investment to get us here. And now what I'm learning is that not just building the AI, but actually industrializing it is a huge challenge in itself. But there, I think we're very well placed now with the right partnerships around us and the right level of expertise to be able to move really fast to see this deployed. So that's what the journey has felt like to me, but today it feels like such a special moment for us in the industry.
It felt like that dam really burst from our side of things last year when you guys raised $1 billion, which a year ago felt like a lot of money, maybe not so much these days. And then the Uber partnership that sort of followed on that. The Financial Times recently reported that you're looking to raise as much as $2 billion now from SoftBank, Microsoft. We know that NVIDIA has already pledged to throw in around $500 million. Jensen, sort of really shouted you out on stage a couple weeks ago over in the UK. How's that deal going? You close yet?
Well, we're always fundraising, and I think this is a long journey for us that we've got amazing shareholders and partners along with that journey with us. Some of the best companies that are at the forefront of this technology, Microsoft, NVIDIA, Uber, and then investors like Eclipse Ventures and SoftBank that are, they live and breathe robotics. So when we're ready to talk about this and announce it, we'll have some more news to share. But right now, we're very well capitalized and we're focused on building.
I believe that. This is the Series D, right? That you're raising?
We've raised a Series C. We'll talk about new rounds when
Why
we're
a
ready.
Series D instead of an IPO?
I think we've got to earn the right to talk about an IPO. I mean, the long-term state of the company is that we want to be the platform for fleets and automakers and robot manufacturers to build these intelligent products. And I think that company needs to be, a public company needs to be independent, trusted to aggregate data and then build such an AI at this level of scale. But we're yet to ship a product and we're really close. We're sprinting on that, and I think we're going to see a proliferation of these products in the coming years. But right now we've been able to access the right level of capital. I mentioned our shareholders in the private markets, and we'll stay focused. We'll build out the products and earn the right to have the conversation about going public.
It's incredible restraint. A lot of companies have gone public without shipping a product. We talked about Jensen earlier. You've had a relationship with him for a while and NVIDIA for a while. They've been involved in your financing before. Was it hard to convince him to get involved with what you're doing? I know now it feels like, easy to think that he's just throwing money around and there's all this money going through the AI ecosystem. But when you first started working with NVIDIA, did you really have to win them over?
Oh, absolutely. I think anyone in Jensen's position is seeing opportunities all around the place. I actually remember meeting him for the first time in 2018. Or maybe 17. We ended up in a lift together, and I had 30 seconds with him. And that reinforcement learning demo I just told you about, I showed him the video and said, hey, we're building end-to-end learning for driving. And Jensen was ahead of the market there. He wasn't dismissive like the rest of the industry. Yeah. In fact, NVIDIA had actually done some earlier research in trying to get end-to-end learning working on cars. And so he was excited about it. And I guess 6 or 7 years later, we've grown our partnership to now be working together with some of the largest manufacturers around the world to bring this technology to market. They've got a fantastic platform. They just announced today Hyperion 10, which is a next generation architecture that we're thrilled to be seeing across many vehicles around the world. And we will work with those vehicles to then deploy our AI driver. So manufacturers, leading manufacturers with the NVIDIA Hyperion 10 architecture and our AI is going to enable consumer vehicles to be self-driving as well as robotaxi and other applications. I think it's actually, maybe being in San Francisco, it sort of feels like everyone's focused on the robotaxi prize, but maybe just to say a few words on the consumer vehicle side of things as well, because of course we aim for our AI to be deployed across both sides of the spectrum. Yeah. But a lot of people aren't talking about consumer vehicles as much because robotaxis, a couple of the leading operators today have a couple of thousand vehicles, but there's about 100 million consumer vehicles produced each year. And I mentioned how an increasing proportion of them now have the equipment on them to be able to actually build autonomy. And I think the first large-scale example of autonomy, where not just in San Francisco or Phoenix or Shanghai, but really where people around the world can experience this, is going to be hands-off, eyes-off, level 3 autonomy. We're really excited to be working on this with major manufacturers, and when consumers can buy a car where you can get in the vehicle and the car will drive you hands off, eyes off, where you don't need to pay attention to the road, you can sleep or read a book. I think this is going to be such an amazing experience that's going to completely transform the automotive industry, but also be the first time people around the world at scale get to experience this. Before, of course, we see robotaxis start to be an option for people in cities around the world too.
I'm still stuck on the idea that you literally elevator pitched Jensen Huang. That vision that you have, Tesla's been pitching this for a while, this idea of licensing its FSD tech and integrating with automakers. They've said that they've had some bites here and there, but it clearly hasn't materialized. Why do you think nobody's bit on what they've been offering for the last couple of years? Why do you think that your solution is going to be better down the road? Well,
I won't speak for our friends at Tesla, but of course their system is vertically integrated into their hardware, their infotainment system. A couple of the advantages that we bring when we talk to manufacturers is we say, look, they're building vehicles right now with the given chips and sensor architecture. We don't bring a hardware stack that says, hey, you need to go bring this into your vehicles, because then that becomes a 3 or 4 year conversation before that can actually be brought to market. We say, hey, look, those vehicles you're building today, our AI can learn to drive them. You don't need to change anything. We can distill down our model, post-train it down to a size that can fit in your specific compute, and fine-tune it on your sensor architecture and work with it as is. So it's a much faster conversation, gives them a lot more flexibility, and we aim to build a partnership that's not, hey, you're just building the metal shell and we'll give you the whole hardware, software, infotainment stack. But actually, let's work with our foundation model where you can leverage the scale, the superior safety, performance, and economics of the foundation model we train at industry scale. But work with our platform to filter on your data, validate it, simulate it, integrate it, and make it work with the UI, the user experience and driver experience that you want, and actually start to personalize the driving behavior. Some of our OEM partners have brought their highly trained expert drivers and said, hey, we want your AI to drive exactly like this. And you won't believe the level of nuance. Like I sit there in a car with one of these drivers and they lecture me about the exact acceleration profile from a red light. And I'm like, come on, man, this is a comfortable drive. But sure. No, it has to be exactly this way. And we can do that with our AI. So this becomes a lot more of a partnership where we can let them shine with their brand, leveraging the scale of our foundation model.
It sounds like the dream for automakers who are looking to cut costs as they adopt new technology. Like, why wouldn't an automaker come to you guys?
That's the experience we've had in the last couple of years. 2 years ago, before 2 years, automakers wouldn't really have a conversation with us. They largely dismissed this approach. Everything changed 2 years ago. We started to see curiosity. Most CEOs of these automakers came for demo drives. And then a year ago, there was a switch where there was a lot more openness to actually start to collaborate and build these things out. And now we're seeing like most of the major automakers really highly engaged and working with us on these products. So it's been very humbling to see this transition. And I think because we were making this contrarian bet on end-to-end deep learning for driving for so many years, it's put us in this position where we have this product ready to go ahead of the market. So look, our team is now focused on how can we get this out across as broad and diverse categories of products across the market as quickly as we can, and that's what we're focused on today.
All right, we're almost out of time, so I want to go through a bit of a lightning round of sorts. Are we in an AI bubble?
I would say, I think no. I think it's not clear who the winners are going to be in AI. I think AI is going to be a massive, sustainable, long-term thing, but the winners that are growing like crazy today, are they going to be the steady state winners? It's unclear.
Yes or no, are you insulated from it if there is an AI bubble?
I think we're just at the beginning in robotics. If you think about cognitive AI, where maybe we're up the S-curve there, but for robotics, we're just at the beginning. We've got the technology, but we don't yet have the products, and that's coming. So I think, I mentioned at the start, everyone's talking about GPUs and data centers and cognitive AI today. In a couple of years' time, that's where robotics is going to come to life. We're seeing that ahead of its time today, and when I think about where you want to spend your time, if you're an engineer working on frontier problems, you want to work on what's going to be the future in 5 years' time. I think that's robotics, and that's why I think we're seeing some of the best and brightest and most talented work on these problems today. So we're right at the start, and maybe robotics will get into the bubble in the future, but we're so far from that right now. There is so much room for growth.
It was not a yes or no, but I'll allow it because you segued to one of my last two questions is, AI companies right now are pretty notorious in some respects for overworking people or for trying to get people to commit to overworking to solve whatever problems they're solving. Is that something that you guys are employing over there, or are you trying to do the work-life balance thing?
I actually think our culture has been a competitive advantage, and I wouldn't call it work-life balance. A startup is intense, but we aim to really build a sustainable, sprint recovery, sprint kind of culture, and you see that in our team. The diversity of our team around the world, Europe, Asia, North America, global geographic presence, very diverse sets of skill sets, backgrounds in our company that we really promote. I'm really proud of our culture. It's really based around ambition to be bold and brave, humility towards the problem, and a sense of collaboration. I think part of that comes with we need to be sustainable. This is not going to be built in a 6-month sprint. The world is going to be changed with a 10-year effort, and that's the company we're trying to build.
Alex Kendall from Wayve, everybody.
Thank you.